In this video, we are solving a problem on sliding friction. The question is asked in such a manner: a block B which is resting on block A is attached by a horizontal rope BC to the wall as shown in figure. The coefficient of friction between the block A and block B is 1 by 4 and that between A and the floor is 1 by 3. Block A weighs 300 Newton and block B weighs 200 Newton. Determine the amount of pull P necessary to cause motion of block A. Also determine the tension developed in the string which connects the block B with the vertical wall. In this problem, they are given two blocks in which block B is placed over block A, and then this block B is attached to the vertical wall with the help of a string, or it has been attached with the help of a cable. And then they have said in this problem the coefficient of friction between the block B and block A is going to be, I am going to take to be as mu suffix 1, which is equal to 1 by 4, and then the weight possessed by that block B is equal to 200 Newton, and then the coefficient of friction between the block A and the floor, that is the horizontal surface, they are given to be as 1 by 3, and the weight possessed by this block A is going to be, first we will be considering the block B and then we will be moving on to the block A. So with respect to the free body diagram of block B, here you can able to see this is our block B. Since this block B is being attached to the vertical wall with respect to the help of a cable, and the tension will be created in the pull direction. Okay. Since the very pull direction, there has been pulling effect has been acting, a frictional force will be acting exactly opposite to the tangentially to the surface, and then FB will be equal to mu1 times of NB. As I already said, I am going to take B or with respect to the block B. So frictional force that has been created in the block B as well as normal reaction has been created in the block B, and then mu1 is the coefficient of friction between block B and block A, and then we will be having a normal force, normal reaction will be acting exactly perpendicular towards the block B, and then the weight will be acting towards the ground direction. And then resolving the forces in horizontal direction, summation f of x is equal to 0, we will tend to get, that is, tension is equal to tension minus f of b is equal to 0, which is equal to tension is equal to f of b, which we will tend to get mu1 times of nb. So this I am going to take to be as equation number 1. And then resolving the forces in vertical direction, summation f of y is equal to 0, we will be getting, that is, w minus w plus n of b is equal to 0. So minus that is minus wb. So it's here wb. And the weight exerted is 200 Newton plus n of b is equal to 0. So we will be getting n of b will be equal to 200 Newton. So substituting this value in equation number 1. So 2 in 1 will tend to get the tension is equal to mu times of, so mu1, that is here mu1 times of nb, that is 1 by 4 into 200. So which will tend the tension exerted between the block B and the vertical wall, that is equal to 50 Newton. Body diagram of block A. In this block A, we know that the mass, that is the weight possessed by the block A, will be acting exactly in the downward direction, and then there has been said in this problem a pulling effect has been acting over the block A, which means when the force has been pulled in this direction, the frictional force will be acting exactly in the opposite direction of that. And then it has been given to be as Fa is equal to mu2 times of Na, where mu2 is the coefficient of friction exerting between block A and then the floor surface. Okay, and then we also know that the normal reaction will be acting exactly perpendicular to the block A along the weight direction. Okay, and then there will be components that will be contributed by the block B, which has been kept over the block A. Okay, and then so what are the components that will be offered by block B over block A when you are going to see? It will be definitely when this block A has been pulled over in this direction, the amount of friction exerting between block A and block B will also be in the direction opposite to that. That is your F suffix B is equal to mu1 times of your NB, and the contribution of your normal reaction over your block A will also be in the direction perpendicular towards your block A, that is here. So taking summation of horizontal force is equal to 0, we know that minus P plus Fa plus Fb is equal to 0. So we can rearrange this equation and are able to get P is equal to Fa plus Fb. So we know that Fb is equal to, with respect to block B, we know that Fb is equal to T, which is equal to 50 Newton. Okay. So substituting the value of that over here, we will get P is equal to Fa. So Fa is mu2 into, what is our value? We don't know the value of Na, plus, that is Fb is 50. So taking this as our equation number 1. And then, so taking the summation of vertical forces is equal to 0, we know that we are having the value of Na minus Nb minus Wa is equal to 0. We know that from, with respect to block B, we know that Nb is equal to 200 Newton. So substituting the value with respect to that, Na is equal to Nb plus Wa. So Nb is 200 and then the weight possessed by block A is 300. So it tends to get Na is equal to 500 Newton. So this you take to be as equation number 2. So substituting the value of Na in your equation number 1. So with respect to your block A, you will see this is your equation number 1 and this is your equation number 2. And substituting the value over here, we will tend to get P is equal to mu2 times of, that is mu2, what is the value for mu2? 1 by 3 times of 500 plus 50. So from that we will tend to get the amount of pull required to move the block A is equal to 216.67 Newton.